Swayam Prabha, free DTH channel for education.
So today we are going to talk about the Bessel's equation of second kind. Okay, so we are going to take the double root and then we are going to talk about that today. So what we are going to do, okay. So what we are going to do today is that we are going to talk about the Bessel equation of second kind mostly. Equation, okay, the Bessel equation, which is given as x square y double dash plus x into y dash plus x square minus nu square into y equal to 0, which we have already seen that. Okay, so we have derived that for nu equal to n, we have derived Jn of x formula, and then J nu of x we have derived. Okay, we obtained what is A to M relation, we have obtained, etc. We have derived. Okay, so in this one we have saying that summation, so x by 2 power nu, I'm going to write only for nu, x by 2 power nu minus 1 power k equal to 0 to infinity, k equal to 0 to infinity minus 1 power k factorial into gamma of k plus nu plus 1 into, okay, I have the term x by 2 power 2k. Okay, this is what we have seen in the last class, and then we derived that, and then we derived some of the properties also. Now what we are going to do is that we are going to derive a similar kind of things for our nu equal to 0 case also. Okay, so let us see that. So let's give a quick recap of what we did in the last class. Okay, so we had the problems Bessel's equation which we got solved. So that is nothing but x square y double dash plus x y dash plus x square minus mu square into y equal to 0, where mu is a non-negative real number. And then we obtained the relation of am, and we obtained what is the relations between a to k and a naught also, that we have derived. And we assume what is a naught also we have assume 1 by 2 power n, 1 by 2 power n into gamma of k plus 1 we have obtained. Okay, so then we have gamma of nu plus 1 we have used, and then we derived this equation also. Now what we are going to do is that we are going to see, and these are all the things which we have did in the last one. First kind of order n we have derived. Okay, so the same thing, x by 2 power nu summation k equal to 0 to infinity minus 1 power k k factorial into gamma of k plus nu plus k plus 1 or k plus nu plus 1 x by 2 power 2k. So that we have derived. Now what we are going to do today is that we are going to derive Bessel functions of order second kind. We are going to say, okay, but now we are going to say for nu equal to 0 we are going to derive, and then using that we are going to extend it for other things also. Okay, so that's what we are going to do now. So as we know, this is satisfying, how we obtain this one, this is satisfying this relation of the Frobenius method. In Frobenius method, we obtained r equal to nu and r equal to minus nu, etc. came, and then we derived that. So in that case, we use that x power r, am into x power m we have used, and from that we derived this one. Okay, so that is the basic idea behind that we derived it. Now what we are going to do is that suppose r equal to nu equal to 0. Okay, r is equal to nu equal to 0. In this case, what is going to happen? This is going to become like not exactly this one is going to come, because first solution we can find it, j naught of x we can find it. Second one, if you want to find, the second solution is also going to be in the same format which is given in that Frobenius method. So that is going to be something into ln x. Okay, so some the y1 into ln x is going to come. Okay, plus summation m equal to 0 to infinity am x power m format is going to be that. This is going to be your y2. Okay, now r equal to nu equal to 0. So for nu equal to 0, the first solution I am going to use it like j naught of ln x. Okay, j naught ln x plus summation m equal to 0 to infinity am into x power m is going to come. Now we are going to use this. Okay, we are going to use this, and then we are going to substitute it here and going to find the answers for that. Now what we are going to do? We are going to use this y2. Okay, y2 is going to be this one, and then I'm going to substitute it in the equation, and then let us find that. So first let us find y2 dash. Okay, y2 dash is going to be j0 by x plus j0 dash into ln x plus summation m equal to 1 to infinity m into, this is x power m. Okay, m into am into x power m minus 1. y2 double dash, okay, y2 double dash is going to be j0 minus j0 by x square, okay, plus j0 dash by x. Okay, so here also j0 dash by x is going to come, so I'm going to put 2 times j0 by x plus j0 double dash into ln x plus summation m equal to 2 to infinity. Okay, so here x power r should come, but r is already 0. That's the reason there is no r. Otherwise there will be r here. Okay, r1 or r2 is r is going to come. Okay, so here r is 0, r nu is 0. That's the reason I'm not keeping it. So m into m minus 1 into am into x power m minus 2 is going to come. Okay, now if you multiply that with x square y2 dash, then this is going to become like x square y2 dash. Okay, let's write it here itself. Okay, let me write x square y2 dash is going to become like minus j0, okay, plus 2 times j0 dash into x plus j0 dash minus j0 plus 2 times j0 x square j0 double dash into x square on x plus x square. If I multiply, this is going to become like summation m equal to 2 to infinity m into m minus 1 into am into x power m is going to come. X into y2 dash, okay, x into y2 dash is going to become like j0, okay, x cancel. Then I am going to have j0 dash into ln x into x is going to be there. j0 dash x into ln x is going to be there. Plus summation m equal to 1 to infinity, okay, m into am into x power m is going to come plus x square minus mu square. Okay, so therefore I'm going to write that x square minus mu square into y. Okay, so that is why this is going to be multiplied. So I'm going to write x square minus mu square into j0 into ln x. So we got to multiply this plus x square minus mu square, okay, into summation m equal to 0 to infinity am x power m is going to come. Now if you see here, okay, so this is going to be, so these two are same, so j0 same, so I'm just cancelling it out. And if I see here, okay, so I'm just going to concentrate only these three terms. So if I take that terms together, what I'm going to get is that I'm going to get, okay, the blue color term, I'm going to write it in a black color. So that is going to become like ln x, I'm going to take it out, okay, ln x. So if I take ln x out, so ln x into, okay, x square into j0 double dash plus x into j0 dash plus x square minus mu square into j0 is going to come. You can see that, okay. So ln x is common, I'm taking it out. So x square j0 double dash x into j0 dash is there, x square minus mu square j0 is there. But j0 is a solution of the Bessel equation as mu equal to 0, okay, or r equal to mu equal to 0. Therefore, this is going to become like this, all these terms going to become like 0. Okay, so therefore I can just cancel these terms. Okay, I'm just going to cancel these terms. So I can cancel those terms. So I have written the same thing in the slides also. You can see that x square y2 double dash plus x y2 dash x square minus mu square. Okay, so mu is nothing but 0 here. Therefore, this term is not going to be there. We are going to get only x square is going to come. Okay, so that's what I have given in the slides also. Okay, so in the next slide. So this is going to become 0, so I can just cancel this out, and j0 going to get cancelled, so that is also going to go going away. So only remaining term what I have is, so the remaining terms are, I have, what are the remaining terms? So remaining terms are only j0, this one, these three terms. Okay, only these are going to be surviving. So I can write this as equal to, okay, 2 times j0 dash into x, okay, plus summation m equal to 2 to infinity m into m minus 1 into am into x power m minus 1 sorry, m only, not m minus 1. Okay, plus summation m equal to 1 to infinity m into am into x power m plus summation m equal to 0 to infinity m into am no m am into am into x power m plus 2 is going to come. Okay, because nu is 0 here, so I'm going to remove that. Only x square is going to come. That I'm going to put it inside that. That is therefore it is going to become like am into x power m plus 2 is going to come. Okay, write it over here due to space constraints and COVID constraints. Okay, so let us write here. Now we have one property that we know one property. The property is that j naught dash. Okay, j naught dash is nothing but j minus j1. Okay, this property we have. J naught dash is going to be minus j1. That property we know. So I'm going to use that. Therefore, that equation is going to become like minus 2j1 into x plus as it is summation m equal to 2 to infinity m into m minus 1 into am into x power m. Okay, plus summation. I'm going to erase this also. Okay, so that I can just concentrate here. Okay, let it be here. After I copy it here, I will just erase this one. So this is j nu is there. Okay, plus summation m equal to 1 to infinity m into am into x power m is going to come plus summation m equal to 0 to infinity am into x power m plus 2 is going to be there. Okay, now what I have, I'm going to use this j1. Okay, I got to substitute new part. I'm going to do, I'm going to substitute what is j1 of x. Okay, j1 of x I'm going to substitute and then we are going to find it. So let us find that. So now what I'm going to do, I'm going to substitute wherever nu is there, I'm going to substitute 1 over here because I got to write what is the formula for 2j1. So minus 2x into j1 is going to become wherever nu is there, put it 1. So x by 2 power 1. So I am just keeping as it is. X equal to k equal to 0 to infinity. Okay, minus 1 power k divided by k factorial gamma of nu is 1. Therefore, I am going to write it as k plus 2. Okay, k plus 2 into x by 2 power 2k is going to come. So 2 gets cancelled. Okay, I can remaining thing as it is. We'll write it. Okay, and this is going to become like x square. Okay, so therefore I can write this as minus summation k equal to 0 to infinity. Okay, minus 1 power k factorial gamma of k plus 2 x power 2k plus 2 divided by 2 power 2k is going to come. Okay, because x square is there, I'm just keeping it inside. Therefore, it is going to become like x power 2k plus 2 is going to come. So the remaining thing I'm going to erase it here. Here also I'm going to erase it. Okay, so therefore what I got, I'm going to have summation, the remaining as it is. Okay, remaining things are as it is. Same thing here, m equal to 2 to infinity, remaining things are as it is going to come. Okay, remaining things as it is. I'm going to get that same thing. Okay, now we are going to compare the coefficients of x. Okay, if I compare the coefficients of x, if you see here, okay, let us concentrate here. If I concentrate here, what is the coefficient of x here? There is no coefficient of no constant terms is here. Okay, no constant terms are here because x square, first term itself is starting from x square. Okay, so remember that first term itself starting from x square only. Here, first term again starting from x square only. Okay, here also first term is starting from x square only. So here the first term is starting from 1. Therefore, what I have, okay, I am having all the terms. Okay, all these things are having x square is there except this one. Okay, except this one, everywhere it is starting from x square. Okay, that remember that. So now if I compare here, what I'm going to have, okay, so if I compare only this one, in this case I have m equal to 1. In that case 1 into a1 into x is going to come. Okay, in the right hand side it is 0, therefore a1 into x is equal to 0, therefore a1 is going to become 0. Okay, if I compare the x power 1 coefficient, I'm going to have a1 equal to 0 is there. Okay, so this one I'm just writing the same thing. Whatever I did a simplification and then I'm doing it. Okay, so Comma of k plus 2 I have written as m plus 1 factorial, because comma of k plus 1 comma of k plus 2 is nothing but m plus 1 factorial is going to come. That's what I have written here. Okay, so you can see it over here. Okay, m plus 1 factorial is going to come. Okay, now what we are going to do, we are going to use so the same thing I have written, okay, again and again I have written that. So you don't need to worry about that. Whatever I have written in the board, that is sufficient. So m equal to 0 to infinity. So I'm going to simplify this further. Okay, a1 x equal to, I'm going to compare only the, first we will compare the x coefficient. Okay, x coefficient if I compare a1 x equal to 0, therefore a1 equal to 0 is going to come. Now if I compare this one, okay, if I compare the r power, okay, there is no r power is going to come from here, because 2k plus 2 is going to be there, no r term is going to come. Now if I compare here, there is r term, there is r term, there is r term. So only I got to take what is there in that one. Okay, so I take it over from here. What I'm going to take. So if I compare, I can write this from m equal to 2 to infinity, because I have already taken here, and this is also m equal to 0 is going to come. So I can write this as again I can write this one as, okay, so let us write the remaining thing. So this is going to be minus k equal to 0 to infinity, okay, minus 1 power k by k factorial. This I am going to write as k plus 1 factorial right now, okay, k plus 1 factorial, or since we have m over here, so wherever k is there, I am going to replace it with m. Okay, wherever k is there, I replace with m, because this is a dummy variable only, indexing is only, so we are going to write m factorial and m plus 1 factorial you are going to write. Okay, so a1 equal to 0. Remember that a1 equal to 0. Keep remembering that. Okay, so I just erase the rest and then I will write it over here. So this is going to become like minus summation m equal to 0 to infinity minus 1 power m factorial into m plus 1 factorial. Okay, into x power 2m plus 2 divided by 2 power 2m is going to be there. Okay, 2 power 2m is going to be there. Now rest of the things I'm going to rewrite this equation as follows. Okay, rest of the things I'm going to rewrite as follows. What I'm going to do is that I'm going to write this as summation m equal to 2 to infinity, okay, m into m minus 1 into am into x power m. Already I have taken that a1 equal to 0 here, therefore it is going to start once again m equal to 2 to infinity, okay, m into am into x power m is going to come. So it is starting from m equal to 2, okay, plus summation m equal to 2 to infinity. Here I am going to make some changes, okay, I am going to make am minus 2 into x power m. So you can verify that a naught x square is going to come. Here also it is going to come a naught x square. Next term a1 x cube is going to come. Here also if I put m equal to 3, a1 x cube is going to come. Therefore both are same. Okay, I didn't change. I didn't make any big changes over there. Okay, so m equal to 1 is already taken care. Okay, that is a1 equal to 0 is there. Okay, so therefore that is going to vanish. Now what I have here, there is no other. Okay, first term there is only even powers are there, no odd powers are there. Here we have even powers and odd powers are there. Now I am going to simplify this. Okay, so this one as it is, this one I am going to write m equal to 2 to infinity. Okay, m into m minus 1 into am into, okay, plus this one again m into am, okay, plus am minus 2. Okay, let me put a big bracket and then x power m. Okay, so I can this these things are as it is. Okay, I'm just going to simplify this one. This is going to be m equal to 2 to infinity. Okay, m into, so I can take m out here, so m square, okay, minus m, okay, plus m into am plus am minus 2 into x power m is going to come. Now if I take the odd powers, okay, whether odd powers or even powers, it doesn't matter. What you are going to get is m and m get cancelled. Okay, m and m gets cancelled. So therefore, what you are going to get? You are going to simplify this. Okay, you are going to rewrite this as m square am. Okay, you are going to write this as m square am is going to come plus am minus 2 is going to come. Am minus 2 into x power m is going to come. Therefore, what is the relation? Okay, so if I compare this power, what I am going to get is that the relation between am and am minus 2 is nothing but m square am equal to minus m minus 2 is going to come. Okay, so that's what we have derived in the next page. Okay, m square am equal to minus 1 into am minus 2 is going to come. Or I can write, if I write m equal to 0 to infinity, that is going to be the same thing. Okay, here m is a3. Okay, what is a3 is going to come? So a3 is going to become, okay, a3 is going to m square a3. So if I put m equal to 3, this is going to be 9a3 equal to minus a1 is going to come, because 3 minus 1. But what is a1? That is 0. Similarly, if I find a5, that is going to become like 25a5 is going to be minus a3 is going to come, but already a3 is 0, therefore this is 0. That means all odd powers vanish. Okay, all odd powers vanish. No odd powers will be there. Okay, only even power is going to be there. Remaining odd is going to vanish. So therefore, I'm going to erase the rest. Okay, I'm going to erase the rest of the things. Erase everything. Only even power is going to survive. Okay, so that is the only thing I'm going to keep it. Now we are going to replace this over here. Okay, I'm going to replace. Now we are going to do some small adjustment over here. Suppose I want to do instead of m, what I'm going to push it that I'm going to here 2m plus 2 is that, therefore I'm going to push that also 2m plus 2. So in that case, wherever m equal to 2 is there, okay, wherever m is there, that it tends to m plus 2. Okay, first you tends that to m plus 2. Then this is going to become like summation m equal to 0 to infinity. Why are we doing that? Because here I have m equal to 0 to infinity. Therefore, this also should be m equal to 0 to infinity. Therefore, I can just compare that. Okay, that's the reason I'm going to do that. So m equal to 0 to infinity. Okay, m plus 2, wherever m is there, replace that with m plus 2, am plus 2, m plus 2 whole square, am plus 2, okay, plus am into x power m plus 2 is going to come. Okay, this is going to come. Because all odd powers are 0. Okay, all odd powers are 0. a1 is 0, a3 is 0, etc. a2m plus 1 is 0. Okay, all odd powers are 0. So here what I have, m equal to 2 is there. Now I have only even powers are there. Therefore, what I'm going to write? I'm going to write m equal to 0 to infinity once again. Wherever m is there, you put that as 2m. Okay, wherever m is there, put that as 2m. So therefore, this is going to become like m plus 2, 2m plus 2 whole square, 2m plus 2 whole square, a 2m plus 2, okay, plus a 2m into x power 2m plus 2 is going to come. Okay, so remember that I pushed m equal to 2 to m equal to m plus 2, so therefore it is going to come. Now what you are going to do, you erase everything here. Okay, I erase everything. Now you can see that. Okay, here also x power 2m plus 2, here also x power 2m plus 2. Therefore, I can take that x power 2m plus 2 common and I can compare the coefficient. Therefore, what I'm going to have, I'm going to have only this. Okay, so I can just erase this. Okay, and I can erase this one also. Okay, erase this one also and erase this one also. We're going to have this one. Okay, this is going to come. Okay, minus 1 power n factorial n plus 1 factorial 1 by 2 power n plus summation 2m 2 whole square a 2m plus 2 plus a power 2 is going to come. So this is going to be 0. Okay, if this is 0, then each term is going to become 0. Therefore, what you are going to get, this implies 2m plus 2 whole square into a 2m plus 2 plus a 2m equal to minus 1 power m divided by m factorial into m plus 1 factorial into 1 by 2 power 2m is going to come. Perfect. Fine. Now you can write that. Okay, so I'm just going to write that over here. Okay, I'm going to find what is the relation is going to come. Okay, minus 1 power m. I'm just writing it as minus 1 power m plus 1. That is fine. Now we are going to find what is the next first term is going to come. Since it is having x square is the first term, okay, there is no constant term is going to be coming over here because the first term itself will be starting from x square only. Therefore, I have to compare what is my a2. Okay, if I compare what is my a2, what is it going to come? It is going to come like, if I compare the a2 term here, okay, what is it going to come? Let us see that. Okay, if I compare the a2 term, so if I compare the x square coefficient, okay, if I compare the x square coefficient, I'm going to get a2. Okay, so I don't have anything about a0. Okay, if I put m equal to 0, this is going to become like a 2m plus 2. I don't have any information about A0. Okay, so I just since that is not there, I'm going to assume that as 0. Okay, so A0 I'm going to keep it as 0. So therefore, what I'm going to have, I'm going to starting from A2. Okay, A2 only I'm going to start. So in that case, what is it going to come? I'm not having any A0 term because I don't have any information about that. So you can just forget about that, and that is not going to contribute anything over here. Okay, so that therefore you can start comfortably forget that. So now what you can do, you are going to put m equal to 0, therefore you are going to put A2. Okay, so here it is going to be m equal to 0, therefore it is going to become like 4A2. Okay, 4A2, and this is comfortably forgotten. And here m equal to 0, therefore this is going to be 1, 0 factorial, 1 factorial, 2 power 0. So it is going to be 2. Okay, so 2 is going to be there. Okay, so no, sorry, 1. Minus 1 power 0, 1, 0 factorial, 1 factorial, 2 power 0, therefore it is going to be 1. Okay, so therefore you are going to get 4A2 equal to 1 is going to come. 4A2 equal to 1, therefore A2 is equal to 1 by 4 is coming. Okay, now A2m plus 2, I am going to write that. Okay, what is A2m plus 2 is going to come. So I can write this. I write this top. A2 is equal to 1 by 4. Okay, A2 is going to be 1 by 4. Now we are going to find. So A2 I have found. Now I am going to write that. What is? I am going to go in the reverse direction. What is A2m plus 2 is going to come. So A2m plus 2 is going to be minus A2m. Okay, minus 1 power m plus 1 minus 1 power m plus 1 or minus 1 plus 1 power m. Okay, so I'm going to write it as minus 1 power m plus 1 divided by m factorial into m plus 1 factorial. Okay, into 1 by 2 power 2m is going to come. Into 2m plus 2 whole square is there. Okay, so therefore what I'm going to write, I'm going to write that on the denominator here. So I put that over here. A2m plus 2, okay, equal to 1 by 2m plus 2 whole square of this one. Okay, 2m. Here 2m is there. Okay, 1 by 2 power 2m is there. Now what I have this relation. Therefore from this one, what you can find, suppose I want to find A2m. Okay, if I want to find A2m, wherever m is there, replace that with m minus 1. Okay, then this is going to become like A2m is going to come. Therefore, this is going to become like A2m equal to, you can observe the pattern. This is going to be 2m whole square. Okay, and this is going to become like minus A2m minus 2. Okay, so 2m plus 2 means 2 degrees there. So I'm decreasing 2 here, minus 1 power. Okay, so wherever m is there, you reduce 1 by that. Okay, therefore it is going to come. So therefore this is going to become like minus 1 power. You are going to reduce that. So wherever m is there, replace that with m minus 1. So therefore you are going to get that answer. So in this case, you are going to get minus 1 power m. Okay, divided by m factorial into first one is m minus 1 factorial. Okay, so first one is I am replacing m minus 1. So m minus 1 factorial into m factorial into 1 by 2 power 2m minus 2 is going to come. Okay, what I can do is that I can write this as, okay, I can write this equation as follows. Okay, I'm going to write it as minus a by 2m. Okay, minus a by 2m, a2m by 2m plus 2 whole square. Okay, 2m to whole square, 2m to whole square. Okay, minus 1 power m plus 1 divided by m factorial. Okay, into m plus 1 factorial into 2 into m plus 2 whole square. Sorry, m plus 1 whole square. Okay, you can see that is 2m plus 2 is going to come. 2m plus 2 whole square is there, that I am writing as 2 into 2, I am taking it out, so m plus 1 whole square into 1 by 2 power 2m is going to be there. Okay, so this one I can write it as, okay, this 2 square is there, therefore I can put 2m plus 2 here and I can remove this over here. Okay, and then remaining what I have is that I have 1 m plus 1 is there, therefore that is going to become like m plus 1 factorial. Okay, m plus 1 whole square is there. Okay, so what I'm going to write it as 1 m plus 1. I'm going to put 1m plus 1 over here. Therefore, that is going to become like m plus 1 factorial. Okay, so therefore I can replace this. Okay, m factorial. I have this one m factorial into m plus 1 factorial into m plus 1 whole square is there. So I can write it as m plus 1 into m plus 1. Okay, therefore these two I am combining. If I combine these two, this is going to become like m plus 1 factorial into m plus 1 factorial into m plus 1 is going to come. Okay, so these two I can write as m plus 1 factorial whole square into m plus 1. Okay, so therefore I'm going to replace this over here as m plus 1 factorial whole square into m plus 1. Similarly, you can do the same job over here. So in that case, it is going to become like, you can see that 2 square going to cancel. Okay, here 2 power m minus 2 is there, here 2 square is there, therefore it is going to get cancelled. So you are going to get 2m is going to come. Okay, 2 power 2m is going to come. Here 2m square is going to come. Here m square is there, so if you put it m square over here, so that is going to become like m minus 1 into m is going to be there, that is going to become like m minus 1 factorial square. Okay, and then you are going to get one more m is going to be there. Therefore, this is going to become like same thing, same way I can write this one as minus a 2m minus 2 divided by 2m whole square minus 1 power m divided by m factorial square into m divided by 1 by 2 power 2. Okay, so this is going to come. Okay, so or I can write this as so here in the slide what I have written minus 1 power m I have written, therefore I have taken 1 m here. I can write this one, and here I have written minus 1 power m minus 1. So that this will be consistent. Okay, so whenever m is there, this is going to be there. Whenever m minus 1 is there, this is going to be there. So in general, okay, so if you generalize this, what you are going to get is that you are going to get okay. Now what I am going to do, we are going to substitute. So a to m I know. A to m is nothing but a to m minus 2 2m whole square minus 1 power m minus 1 m factorial m into 1 by 2 power 2m is 10. So now we are going to substitute it over here. Okay, wherever I have this one, I am going to substitute it over here, and then we are going to simplify what is the answer is going to come. Okay, so I erase everything. We have what I have. I'm just going to replace a to m over here. Therefore, this is going to become like a to m plus 2 is going to become like this. A to m plus 2 is going to become like minus a to m. I have to replace. Okay, so I have one thing a to m. So this is the one I have to replace using this one. Okay, so therefore what I'm going to have, I'm going to have 1 by, so this one 1 by 2m plus 2 whole square. Okay, minus I'm going to use a to m is this one. Okay, so therefore this is going to become minus a 2m minus 2 divided by 2m whole square is going to be there. Okay, minus 1 power m minus 1 divided by m factorial square into m into 1 by 2 power 2m is going to be there. Okay, this is 2m plus 2 whole square. I replace only 1 by 2 power 2m. Then I have this term also plus minus 1 power m divided by m fact plus 1 factorial whole square into m plus 1 into 1 by 2 power 2m plus 2 is there. Okay. So these are the things are available. So you're substituting it over here. Therefore, you are going to get this one. Okay, minus 2m minus 2, 2m whole square minus 1 power m minus 1, etc. is there. Okay, now I'm going to simplify this further. Okay, I'm going to simplify this. So I multiply this. So this is going to become like minus 1 into, so minus into minus plus is going to come. So I can just replace that. Okay, this is going to become like a plus, minus into minus. Okay, plus is going to come. Okay, a 2m minus 2 divided by 2m plus 2 whole square into 2m square minus, this is once again minus into minus, plus is going to come. Sorry, here plus is there. So minus is going to come, minus into minus is there. So minus 1 power m minus 1 divided by 2m plus 2 whole square into m factorial square into m into 1 by 2 power 2m. This one as it is. Okay, I don't change anything over there. Let's simplify this further. What we are going to do? Okay, let us simplify this. So in this case, what we are going to have, minus 1 by 2m plus 2 is there. Okay, so etc. is there. I'm going to simplify this. So this is going to become like, I can write this as a 2m minus 2 divided by 2 square, okay, 2 square m plus 1 into m whole square. Okay, I'm taking 2 square out, 1 2 from here, 1 2 from here, therefore 2 square into m plus 1 into m whole square is going to come. Minus here, what I'm going to do, minus 1 power m minus 1. Okay, so again I'm going to put 1 minus over here, therefore it is going to become like minus 1 power m is going to come, and then I'm going to take 2 square 2 out here. Okay, this is going to become like, I'm just going to put it minus and minus plus, so minus 1 power m I'm going to take. So take a 2 out here and put it over here. That this is going to become like 2 power 2m plus 2 is going to come, and this is once again m plus 1 whole square is there. Okay, m plus 1 whole square, it is there. M plus 1 whole square is there. Okay, m plus 1 whole square, and m factorial is also square. Therefore, I can replace this as m plus 1 factorial whole square. Okay, into m is there. Okay, this m is there. Plus here what I have. Okay, here I have again minus 1 power m plus 1 factorial whole square. Okay, m plus 1 into 1 by 2 power 2m plus 2 is there. Okay, so this is going to be as it is. I'm not going to change anything over here. This is going to be as it is. So here minus 1 power m, 2m plus 2, m plus 1 factorial square is common. So I can take it out. So here plus minus 1 power m, 2 power 2m plus 2. Okay, m plus 1 factorial whole square. I'm going to take it out. Then remaining I have 1 by m here and 1 by m plus 1 is here. Okay, remaining thing as it is. This one as it is. A to m minus 2 is as it is. I don't change anything. Now I can proceed this further. Okay, if I proceed further, what I'm going to have is that I'm going to have similar kind of expression I'm going to have. So if I keep on decreasing, okay, so again I can replace what is a to m, what is a to m minus 2, again I am going to get it in a to m minus 4, then again a to m minus 4 I can write it as a to m minus 6, etc is going to come. So after a certain stage, what you are going to get is that the similar way, suppose I keep on doing the same thing, what you are going to get is that you are going to get, so first time it was minus, second time it is plus, so third time it is going to become like a 2m minus 2 is going to come. Okay, 2m minus 4 is going to come. So I can write 2m minus 4 here. Okay, or 2 into m minus 2 I can write it. Okay, into this is going to become like, first time it was 2 into m plus 1 whole square. Now this is going to be 2 square. This time it is going to become like 2 plus 3 is going to come. 2 power 3 is going to come. Okay, you can observe that pattern. M plus 1 into m minus 1 is going to come. Okay, first time it was m plus 1, second time m plus 1 into m is there, third time it is going to become m plus 1 into m minus 1 is going to come. Plus, okay, I'm going to write that again here. What I'm going to get? I'm going to get minus 1 power m, 2 power 2m plus 2 is going to come. Okay, here it is going to become like m plus 1 factorial whole square again into 1 by m plus 1 by m plus 1 plus 1 by m minus 1 is going to come. Okay, so this is the one which I have. So you can keep on decreasing. Okay, if you keep on decreasing up to 0, you can do that. You can extend this further. Okay, if you keep on decreasing this one, so there is a whole square here. Okay, so if you keep on decreasing this, what you are going to get is that after a certain stage, you are going to get this answer as follows. Okay, I will show it in the next page. So if you keep on decreasing, what you are going to get is that it is going to become like, what I am going to do is that, suppose I do that at the jth step. Okay, at the jth step, what is going to be there? Okay, so j equal to, suppose j equal to 0th stage we have 1, j equal to 1 stage we have 1, j equal to 2 stage we have 1, etc is going to come. Now if I take the jth term, what you are going to get is that you are going to get, so j equal to 3 means you are going to get this one. So here you are going to get minus 1 power j minus 1 is going to come. Okay, j minus 1. Okay, so j minus 1 into, you are going to get a 2 m minus j is going to come here. Okay, m minus j divided by, you are going to get here 2 power, you are going to have 2 power j plus 1. Okay, so if 2 is here, 3 is there. Therefore, if I put j here, this is going to be 1, j plus 1 is going to be there. Okay, and here, if 2 is there, I'm going to put j minus 1 or j plus 1 also you can put, that doesn't matter. Okay, minus 1 power j minus 1 or j plus 1 you can put it. So 2 power j plus 1 is going to be there. Here it is going to become like m plus 1, m minus 1. So up to what stage it is going to come? If it is 2, it is going to be 1. Therefore, if it is last one, it is going to become like m minus j plus 1 is going to come. Okay, m minus j plus 1 is going to come. Sorry. So last one, it is going to become like m minus j equal to 2, this is going to be satisfied. Okay, m minus 1 is going to come. Plus minus 1 power m. Here no change, 2 power 2m plus 2. Okay, 2 power 2m plus 2, m plus 1 factorial whole square. Okay, into 1 by m plus 1 by m plus 1 plus etc. 1 by m minus j plus 1 is going to come. Okay, up to this it is going to come. Now what you are going to do, replace wherever j is there, replace that with m minus 1. Okay, wherever j is there, replace that with m minus 1. In that case, what you are going to get, okay, if I replace wherever j is there, replace that m minus 1, then in this case, minus 1 power j power m minus 1. So I can replace this as minus 1 power j power minus 1. Okay, so the j minus 1 is going to be m minus 2 is going to come, or I can write it as j plus, either I can write j plus 1 or j. So it is going, I can write it as minus 1 power m. Okay, so therefore you can put in the previous slide minus 1 power j plus 1, that is going to satisfy. Then, so j plus 1, so j equal to m minus 1 means j plus 1 is going to become like m. Okay, j plus 1 is going to become like m. So this is going to become like m here, 2 power m. Okay, and this whole square is there here. Okay, because the whole square is there. M plus 1, m minus 1, etc. Again, j plus 1 is going to become like, okay, my m minus j plus 1, that is going to become like, you are going to get wherever j is there, replace with m minus 1. Therefore, minus m plus 1 is going to come. Therefore, this is going to become like 2 square is going to come. This is going to become like 1 plus 1 whole square is going to come. And here, m minus j, therefore, if I put j equal to m minus 1, m get cancelled, only 1 is going to be there. Therefore, it is going to become like 2a2. Okay. Here, it keeps on decreasing. Okay, then you are going to get up to 1 by 2 is going to come. Okay, because m minus j plus 1, if I put m equal to j equal to m minus 1, m get cancelled, so 1 plus 1, 2 is going to come. So up to this it is going to come. Now what I am going to do, I am going to substitute a2. What is a2? A2 is going to be 1 by 4. Okay, if I substitute a2 equal to 1 by 4, then what I am going to have? I am going to have one more term is going to come. Okay, 2 square is 1 by 4 is going to come. Therefore, this I can rewrite it as, so this is going to be 1. Okay, and this one I can write it as m plus 1, because already square is there. And what is this one? M plus 1, m into m minus 1, etc. is going to be there. Up to 2 is going to be there. So that is going to become like, I can replace this one as m plus 1 factorial square. Okay, factorial square. Factorial square. So that means, again you can see that. Okay, so here what I have 2m plus 2 is there. Okay, I write this one, 2 power 2m plus 2 is there. Okay, so you can see that here also 2 power 2m plus 2 minus 1 power m is there, 2 power 2m plus 2 is there, m plus 1 factor is there, same thing is going to be there. Therefore, I can absorb this, inside this one. Okay, that is going to be one more term is going to come. Okay, one more term is going to come, that is going to be 1. Okay, whatever I have here, that I absorbed over here, therefore this is going to be your final term. Therefore, what you got? You got a to m plus 2 is this one. A to m plus 2 is going to be this one. That is your a to m plus 2 finally. Okay. So this is the one which we are writing. Okay, this is the one which we are writing, a to m plus 2, because my original series, if I remember, okay, if I remember my original series, what is the original series? The second solution is of this kind. It is going to be only r term is going to survive. Okay, so that is going to be my y2 is going to become like y2 is equal to j0 into ln x, okay, plus summation m equal to 0 to infinity. Okay, only second term, only the term which is going to be like a to m term we have found. Only a to m 2 plus term is going to be there. Remaining term is going to become like, we are not going to get that. So in that case, what you are going to get? You are going to get minus 1 power m. Okay, I am going to replace whatever is here. I am going to replace that 2 by 2 power m plus 2. Okay, into m plus 1 factorial whole square. Okay, into 1 by I just write it in the other order, 1 plus 1 by 2 plus etc. 1 by m plus 1. Okay, into x by 2 x power 2m plus 2. Okay, x power 2m plus 2 is 2. Or I can simply write this one as, okay, I just rewrite this equation in another format. Okay, so this one I can write it as equal to j0 into ln x plus summation m equal to 0 to infinity minus 1 power m divided by m plus 1 factorial square. Again summation. Okay, summation. Let's put n equal to 0 to n equal to 1 to, okay, n equal to, yeah, n equal to 0 to m, okay, 1 by n plus 1. Okay, you can see that when n equal to 0, this is going to be 1, 2, etc. up to n plus 1 is going to come. Okay, into x by 2 power 2m plus 2. This is the one I can write it. Okay. So this is the one which I have for our, so R I have written k equal to 0 to k plus 1, both are same. Okay, instead of n equal to 0, I have written k equal to 0 by k equal to 0, 1 by k plus 1 I have written. Okay, same, both are same. Now what we are going to have here is that here I can write not only this one, I can write a by 2. Okay, I can write y2 is a solution. Okay, j1 j0 is a solution. So I can write j0 and y2 are linearly independent functions. Therefore, what you can write is that you can write some a constant into y2 plus constant into j0 also is going to come. Okay, a into y2 plus b into j0 also I can write. That is also going to be a solution. Now, what I'm going to choose? I'm going to choose something like this. Okay, I'm going to choose a into y2 plus b into j0. I'm going to choose. Now, what I'm going to choose? A is equal to 2 pi and b equal to gamma minus ln 2. Okay, if I choose that one, then what I'm going to get is that I'm going to get a Bessel function of the second kind of order 0, which is nothing but y naught of x. Okay, y naught of x I say. So that is going to be 2 pi into j naught into ln of j naught of x into ln of x by 2 plus gamma is going to come j naught into, okay, because I have chosen b equal to gamma minus ln 2. Therefore, this is going to become like j naught into ln of x by 2 plus gamma, okay, is going to come plus remaining term as it is. Okay, remaining term I'm not going to change anything. Remaining term as it is going to come. Okay, so this is called y naught, or the Bessel equation of Bessel functions of the second kind of order 0. Okay, so this is the equation for that. Now we can see that as x tends to 0, okay, this is going to become like y naught of x tends to minus infinity, because there is a ln x term here. You can see that e power x tends to 0 if x tends to minus infinity. Okay, therefore ln x is going to be ln x tends to minus infinity. Okay, ln x tends to when x tends to 0, ln x tends to minus infinity. Okay, when x tends to 0, ln x tends to minus infinity, because you can take the log on both sides. So as x tends to infinity minus infinity, ln x is going to x tends to 0, ln x is going to become like minus infinity. Okay, so in that case, what I can say, I can write this in general the Bessel function of the second kind of order nu, which can be written in this way: y nu of x is nothing but, I can write this as 1 by sine nu pi, which you can derive. Okay, once again, it's a lengthy process, so you can derive that. So j nu into cos nu pi, okay, cos nu pi minus j minus nu of x. Okay, so this is the Bessel function of the second kind of order nu. Okay, in general you can write yn. Okay, yn you can write it in this way also. So 2 pi into jn into ln x by 2 plus gamma, and again you can put x power n pi, you can take it out, etc., etc. You can do it. Okay, so means you can do similar kind of job. Okay, but you have to write in terms of n and other terms you got to write. So you can I'm just giving the equation only. I'm not going to derive anything. So you can just see that yn of x equal to 2 pi jn of x. This is going to be the Bessel function of the second kind of order n in general. So now suppose some problem is given. Okay, suppose some Bessel equation is given of order nu. Then what you can do is that you can write the solution of the function, solution of the equation. If you find what is your nu by transformation or some simplification, what you can do is that, suppose you find what is the new term over there. Okay, if you find the new term, then in that case, what you can do is that you can write that solution. Okay, suppose you found the new in that problem, then you can write y of x equal to some c1 into j plus c2 into y new of x. Okay, so that is going to be the general solution of the Bessel equation. So you'll see one or two problems and then you will understand. So a few problems on Legendre's and Bessel's equation we'll see. So this is the Bessel function. You can see that. Okay, so we can just see that this is going to be like oscillating j naught of x. You can see that is starting with 1. We have already you can observe that. Okay, j naught of x is going to become like j naught of 0 is going to become like 1, and then it is going to decrease, and then after subtraction it is going to oscillate, and then it is going to come up, etc. So this is oscillating one. Okay, because you have x by 2 power n, so it is going to be oscillating, and you can observe that also. Okay, what is j naught of x? Similarly, j1 of x is something similar to the sine function, but it is going to oscillate once again. Similarly, the remaining thing, it is starting at 0, and then it is going to x equal to 0, it is going to start at 0. Okay, so it is going to come over. Similarly, you can see the figure for Bessel function of second kind. So as I mentioned, yn tends to minus infinity as x tends to 0. So you can see that y-axis is an asymptote to this curve. Okay, so it is starting at x equal to, so when x equal to 0, it is almost starting at minus infinity. Therefore, it is coming in this way. Okay, so this is the Bessel function of second kind. Now let us solve some problem. So as I mentioned here, we will solve some problem. So suppose you have the equation x square y double dash. Okay, x square y double dash plus xy dash, okay, plus x square minus 16 into y equal to 0 is given. Okay, so in that case, what you can do is that, what is your new? New is nothing but 4. Okay, therefore your solution is going to be y of x equal to c1 into j4 of x plus c2 into y4 of x. Okay, that is going to be your solution.